class. Hello. This is Mr. Moore in the morning. We are coming to you live from Ontario, Canada, where the weather has been beautiful for the last couple of days. If you're living in southern Ontario right now, it is the experience of the icy gauntlet of winter finally slackening its grip. It's wonderful. The snowbanks are melting and everything is absolutely fantastic. So, to your question about one of your test submissions being graded instead of the other, if you don't mind, we can deal with that one either during office hours or privately by email. I'm not sure which of those you would prefer, but I'm just going to say that this is not the appropriate time or place for that type of inquiry. What? It's gonna be 19 degrees today. Oh man, I wish I hadn't so much work to do, or else I would be out gardening. It's gardening weather. You know what? Winter is coming. Oh, don't say that. Don't say that. Don't say that. And incidentally, as far as I'm aware, my cats are of terrestrial origin. Yeah, I should get my gardening done while I can then, huh? All of my bushes need pruning. I need to prune my apple tree so that I might get a good crop of apples this year. Last year in the fall, I planted a crabapple tree because I didn't realize that my apple tree required a crabapple tree for pollination, so I didn't get any apples at all last year. Yeah, so decimal with a capital D is the name of the library. Decimal within... So we're going to get into it when we talk about classes, but essentially what you're doing when you say from decimal import decimal is there's a difference between the file decimal and the class decimal. So I believe the capital one will be the class, because usually class names are capitalized. But cool. Yes. So essentially the programmer's trick is you try a bunch of things, and whichever one works, you go with that, and you don't ask questions. That's how real programmers work. So, this is cool. But enough talk! Have at you! The apples in my tree are always small, and the birds get them. Ah, yes. I have, on my property, we've only been on the property for a couple of years, but I've been obsessed with planting all kinds of various fruit bushes, like blueberries, and you know, you can get dwarf Saskatchewan cherries and stuff like that. And oh, is my camera and mic gone again? Oof. Yes, thank you. That was inevitable because I didn't have to set these things at the beginning, and normally if I have set them at the beginning, that means that they're gonna go shortly into the lecture. Yep, there's the mic. At least I'm not on a particularly stupid face this time. Boop. Ba-doop. Ba-doop. There we go. Ta-da! Well, what you need to do is you need to set up netting. That's how you keep the birds out of your raspberries. Is you have to net them, and it's not that much work to net stuff. That's how I was able to acquire enough grapes from my potted grapevine that I salvaged from the yard, in order to be able to make a full batch of grape jam last year. So, yep. So, might as well get into it. Enough! But enough talk! Have at you! That's a Symphony of the Night reference for all my gamer bros out there. Or gamer gals. We want to be inclusive. So, this topic's going to be a shorter topic. It's not as sort of... This particular topic does not require the same degree of mental real estate that the preceding two topics have. That being said, you still need to know how it works and how to do it and all kinds of stuff. But this is, this is like the deep breath before the plunge when we talk about classes. So, let's talk about testing and exceptions. So, as people who have been programming for at least a couple of months now, it is entirely possible that you guys have run into the dreaded bug. Hands up, anybody who in the class who has been programming so far and has not had a single bug occur. This is the point at which, if we were in a physical classroom, nobody would raise their hands except for a few guys who are like, I don't bug. And I would point at them and they'd say, "You're a liar!" Everybody has bugs. So, this idea of the bug, or the glitch, this is... In order to sort of get into this topic, let's first define our terms. So, what is a bug? Bugs, what are they? We talk about them all the time, but what are they? Well, a bug is anything in the program that causes your program to behave in an unexpected manner, or in a manner that's not congruent with the requirements, right? So, for example, when you are doing an assignment question, the assignment will specify you need to use these inputs to produce these specific outputs. Sometimes there's something in the middle about how you might go about doing that, but generally speaking, most of the assignment problems are sort of, they specify the input, they specify the output, and all of the bits in the middle, which is the actual algorithm, that's up to you. When, for particular inputs, you get the wrong output, or not the expected output, that is what constitutes a bug. Basically, it's when you get the wrong answer. So this here is a algorithm. In terms of input, we are taking a string. It's a base 10 number represented as a string. And the output is the product of the 12 adjacent digits that have the highest product. So if you imagine, a series of, decimal digits, whatever 12 consecutive numbers in there have the highest product, whatever that product is, that should be the output of this particular algorithm. So can anybody spot the bug here? Anybody? It's not for a couple of slides, so if you have any... okay. If you can think of it, we'll just please put it into the chat, and we'll get there when we get there. Let's see. Oh my god. Yeah, well, so to that issue, actually, that's an interesting little small divergence. So when you're working on developing a software system of any size, especially if it's like a personal project, let's say, where you haven't necessarily, spent the effort in rigidly formalizing what you want in the output product. To some degree, like, as with a lot of different types of projects, sometimes your output is a little bit flexible, right? I'm thinking in particular of my own sort of hobby work on video games. When I, every once in a while I get a little bit of time and I plug away at making video games that I release on Steam, which are mostly like, portfolio projects, but, it's good to keep your skills sharp, right? So, often when you're making a video game, when you're programming away, you'll get you'll implement a feature, and as you're testing your feature, or playing around with the game, because, the correct thing to do when you're developing it is, you code a little bit, you try it out. You code a little bit, you try it out. You don't, it's the programmer's mantra, test early, test often. Basically, every single time you implement any distinct functionality inside of a program, you immediately want to test it to see if it's working, right? And this is actually on point with this topic, so I'm totally justified in this tangent. But sometimes when you test out something that you've written, the functionality that it gives you is not what you expected. So in that sense, it's a bug. But it's not necessarily bad either. I'm trying to think of, in my particular case, a bug that became a feature. I can't think of any at the moment, but if my hind brain, which is working on the problem at the moment, thinks of something, I'll let you know. But going back to the civilization game Gandhi example, that business that we talked about where Gandhi's AI goes berserk and he starts nuking everybody. Although that was a bug, it turned out that it provided interesting gameplay, or, it sort of had cultural cachet among the gaming community, at least. So, I'm not sure if they still do this, but I think in a few of those games, they left that in intentionally. So the bug became a feature. That is to say, something that was unintended functionality was deemed to be, was deemed to add to the product rather than take away from it. So, I believe in chat, the thing that Christoph is referring to with respect to Quake is, I believe there was something about, like, if you like explode a grenade underneath your feet, you can do a super jump, and it doesn't make a lot of sense. I think you can do this in TF2 as well, but, it turns out that it's like a really fiddly thing to do, but it's like just possible enough that a highly skilled player can like perform these like rocket jumps, which adds to the skill cap of the game. So with respect to that, that's another example of a bug becoming a feature. So, bugs are not always something you want to squish, but normally they are. It's quite rare that a bug will be a feature. So, how do you detect a bug? How do you know if a bug has been detected? Well, often you can sort of find bugs using test cases. That is to say, in order to demonstrate the existence of a bug, you need to have actually run the program at some point. So when you run the program, obviously, the program is going to, so there's an art to it, actually. So there's an art to designing test cases such that they are likely to come up with bugs. Normally what this means is having the test cases push on, all of the pieces of code that you've written. So, for example, if you've, I'm kind of getting ahead of the slides a little bit, but if you have a piece of code that has two if branches, right? You would want a test case that minimally you would want test cases that cover both of those if branches, because you can have a bug in one and not in the other. And if you're only ever testing the first if branch, and then, you know, the product is released and the second if branch gets, you know, tested or not tested, or it doesn't, you know, it will be tested by the people who use your program, even if it is not tested by you. So that's called coverage testing. And we'll get into it. So another way of detecting bugs is to have another person independently implement your function and see if you get the same answer. So this is a little bit more costly. I imagine there's a fair amount of this that goes on during the assignments. People are sort of, you know, oh, what did you get for question 3? What did you get for question 7? That sort of thing. Which is strongly discouraged on tests, by the way. And another way is to have another person read your code and see if they can find any flaws with it. It turns out that testing code is a sufficiently big deal. It's a sufficiently skilled operation that there are many people in the software industry whose their whole job is testing, software quality assurance. This is what we're talking about right now. Let me see what rocket jump, strafe jump, and many other glitches were deemed to add to the game, and it was more fun and are found in many games today. Yeah, like TF2 uses rocket jump. So, yeah. So, testing and debugging. These are important terms. The goal of testing is to determine whether a program works as intended or not. Debugging is the process of trying to fix a program that you already know has a bug. So, you test to find bugs, and you debug in order to remove bugs. At this point, I have to have another brief tangent into the history of computing to elucidate for you the origin of the term bug and debugging. So, cast your minds back to the heady days of the 1950s and the 1960s. During these days, way back in ancient history of the 20th century, a computer was, you know, your typical computer would have been about the size of my house, right? And the reason that that computers were so large is because this was before the development of solid-state electronics. So, fundamentally, the fundamental device that makes all computing possible is a thing called a transistor. So, transistors have had various iterations over the course of the 19th and 20th centuries. So essentially what a transistor is it's a switch. It's just like a light switch, right? It can direct electrical flow in one way or another, or it can block it or let it through. So there are, you can make these things magnetically, right? So if you make a solenoid coil, electrical current through a solenoid coil induces a magnetic field. A magnetic field may then be used to close an electrical contact, and that is what a relay is. Relays are very often still used in industrial circumstances because a relay, you can use relays for very high power applications, like high voltage, high amperage applications. Stuff that would just fry sensitive electronics. From there, we progressed to the vacuum tube transistor. So vacuum tubes, I'm kind of ashamed to admit this, but I'm not actually sure what the physical operating principle of a vacuum tube transistor is. But basically, they're about yay big. If you're like into rebuilding old radios, you can still buy these things. So vacuum tubes are great. They're in a step up from relays because they don't require as much amperage, but they're large, right? So basically, when you're talking about the equivalent circuitry that's in my webcam right now, you had just this vast room in a building just filled with these vacuum tubes. So back in the day, and we're even we're kind of talking about the era where software was just becoming a thing, because of course the original computers were entirely hardware, right? They were custom built, purpose built electronic circuits that would calculate things. So back then, a computer that filled an entire room would be vulnerable to the same sorts of things that your house is. So it would be vulnerable to, for example, mice living in it, or rats living in it, or bugs, right? Insects. So because these things typically had a lot of open electrical contacts, what could happen is a small creature, like an insect, or a mouse or something, could get inside of the computer, not realize that there's live voltage in there, fry itself, and close two electrical contacts that weren't meant to be closed. Now, most of the time this wouldn't cause the computer to crash. It would just behave it would cause it to behave in an unexpected manner. So these things so the colloquial term developed, bug. An error in the system is a bug. And when you debugged in the 1950s, that meant physically climbing inside of the computer with a pair of tweezers and checking the electrical contacts to see if there are any moths in it or something, and then pulling them out of the machine. So that's the origin of the term debugging and bugs. Maybe that was interesting for you. Maybe not. Anyway, I always think it's useful to integrate a little bit of the history of the science into these lectures, because, it is an introductory course, so, I don't know, maybe it's stuff you haven't heard before. So, generally speaking, when you write a program, these are the steps that you should be going through. And right now, we're talking about programs in their larger iteration, like something that you might actually release commercially, or, something that would have application outside of being submitted for an assignment, right? So, I would say that this is actually, there's a step before this, which is you need to decide what it is that you're programming, right? You need to decide what your inputs will be and what your outputs will be. What is the expected behavior of your program? Otherwise, what are you comparing it to? But you first document, then you write your program. Next, you try to compile your program. So this is basically checking for syntax errors, right? If your program has syntax errors, then it won't even compile, so you won't be able to get anything to be able to test. This is a little bit more... in Python, the edges kind of get a little bit blurred. Some of you may have noticed this, but Python actually checks for syntax errors as it's executing, because it's an interpreted language rather than a compiled language. Other programming languages, such as C, will go through the entire program and compile it all at once, and then try to execute it. As a result, in C, if there's one syntax error in the entire file, it won't compile and you won't be able to execute it. Whereas in Python, you could have a syntax error on one branch of an if statement and it wouldn't actually show up until, unless that branch of the if statement were executed. So, once you have a program that is executing without problems. You then want to test it. Test cases are often provided in the assignment material. It's a good thing to learn how to develop your own test cases. When you run a test case, you should have a set of inputs that match some expected output. If there's a mismatch between the input and the output, you know you have a bug. You go back into the source code, fix the bug, and then retest it to see if the bug has been fixed. Oop. Oh. Did my cam just go again? Oh, jeez. I'm just having the worst time today. It's kind of a funny face, though. I wish I knew what was causing this. Speaking of bugs, eh? Ah, well. That's what you get with open source software. So, generally speaking, testing methods are divided into two categories. You've got so-called white box testing, and you've got so-called black box testing. Now, it's a little bit of a misnomer. What this should really read is transparent box testing and opaque box testing. So if you understand white box, black box as, clear and opaque rather than as colors, that's much closer to the intended sort of, I don't know, white and black are both monosyllabic, and, that's probably why they're being used in this context. But, so, the key difference between white box and black box testing is that in white box testing, you are relying on being able to see the source code, whereas on black box testing, we do not rely on being able to see the source code. You rely solely on the ability to see the inputs that go into it and the outputs that come out of it. So all of the testing that we do on the assignments is, in fact, black box testing, because, the testing that we perform, we're not looking, generally speaking, for a particular construction when you do a problem. That's kind of like one of the bigger differences between this course and sort of your generalized math course, because there's a very, very heavy emphasis in this particular course on the problem solving aspect. I'm really trying to inculcate in you guys the idea of programming languages as tools for problem solving. Algorithm design is the primary focus, I would say, or at least we try to make it the primary focus. That's not always the way in which programming is taught. Sometimes programming is taught, if you're in this situation, you use this combination of loops. If you're in that situation, you use this type of construct. It's more like problem response memorization, right? Whereas we, like in this course, we're trying to foster an understanding of what the constructs actually do, which hypothetically speaking, makes you a much better programmer when you're finished with this course, because it means that you can handle situations that we didn't cover in the course, which is kind of the whole point of a university education as such. So we use black box testing. We're not relying on your programs having any particular structure. So in both cases, what is absolutely essential is a clear specification of the program's expected behavior. It is impossible for basically, it is from the specification, in the assignment context, read the question. It is impossible without a specification to have an idea of correctness. The idea of correctness, what constitutes correctness for this program, is derived from the specification. It doesn't matter how you test it. The question becomes, what are you testing it for? So, let's talk a little bit about black box techniques. Again, they don't rely on knowing the program's source code. They only rely on the ability to put an input in and see the corresponding output. This focuses on the development of test cases to see if the actual output matches the expected output for a given input. Cool. So, just to remind you of our software design principles, generally speaking, when we are designing programs, we always want to have an eye on modularity and abstraction. Once again, modularity is the Lego brick approach to making a program. Programs should be broken into parts that are A, reasonably self-contained, B, can achieve a clear purpose, and C, can be reused. So, the achieve a clear purpose basically means you have well-defined specifications for this module. So, let's pull a recent example. On test 2, the much beleaguered question that involved vectors and matrices, that is a problem that broke reasonably into sub-problems. It was highly possible to take that program and write a couple of functions which would implement that specified behavior. So one operation that was necessary throughout sort of the main execution of that problem was to calculate vector magnitude. That is a subcomponent that is reused quite a bit in that problem. It achieves a clear purpose. You take a vector in and you get the magnitude of that vector out, and it's reasonably self-contained. It doesn't, all you need in order to calculate vector magnitude is the vector itself. It doesn't require any extra information, right? So long as you can pick the vector out of the matrix, that's all you need to be able to do in order to calculate its magnitude. So, because of that, the actual calculation of the magnitude, that could be constituted, as a module within the larger problem. So I would say that doing the magnitude as a function, if on the test you wrote a separate function for that calculation, I would say you are doing well in understanding the advantages that can be derived from designing your software in a modular manner. So abstraction is kind of a property of modularization, I would say. When you have designed your software to be adequately modularized, once you have sort of adopted the Lego view of software, you can apply, basically, you get the principle of abstraction for free. And what the principle of abstraction allows you to do is it allows you to not worry about calculating, it allows you to not worry about the contents of, these modular functions. Just the angle I was at, I couldn't see the red light on the camera to see that it was on. Is the camera on? Have I lost the camera again? No, I think it's good. Okay. It would be really useful and helpful if that red light went out when the camera went off. That would be super, super handy, because then I'd have a visual cue, But anyway, so when you have so abstraction is a really, really, really useful thing because software can get quite complicated. And the more complicated it gets, the higher the need to be able to abstract different pieces of it in order to reduce the mental load required to program. And trust me, if you haven't hit your limit with respect to mental load and programming, you will. You will. Perhaps even within this course. So, designing your program in a modular manner enables better black box testing. Again, going back to the example of vector magnitude, if you wrote vector magnitude into a separate function, that separate function may be tested separately from the rest of the program. So, you can just feed it a couple of vectors, see if it's calculating magnitude correctly, because, you have a sort of on paper, on calculator version of what vector magnitude constitutes, and you can check your calculator version versus the version that Python is giving you. But that's only possible in this sort of nice, simple, clean, and efficient way if you've abstracted the magnitude operation and placed it separately. Otherwise, what you do is you do print statements at various points in the program to show you the internal state. So it's the difference between the internal and external state of your program. You can develop test cases for every function within a program to ensure each individual function works as expected. So this is called unit testing. So taking your magnitude function, testing it separately from the rest of it, you're performing what's called unit testing. What you then want to do is develop some tests to ensure that the program as a whole is working as expected. So it's not sufficient that all of your Lego bricks work individually. You also have to ensure that your Lego Death Star works. The Lego Death Star is more than the sum of its parts, right? Any piece of software is greater than the sum of its functions. So it is, and basically the reason that this is necessary comes down to, again, the Lego analogy holds pretty well. Just because you have a bunch of Lego bricks doesn't mean you're putting them together correctly, right? So integration testing is you checking to see that you have put all of your Lego bricks together correctly. Regression testing is another type of testing. Basically, unfortunately, it can sometimes be the case when you fix a bug that you introduce new bugs as you're fixing one bug, right? Entirely possible. Sometimes it's that new bugs are introduced by the fix to old bugs. Sometimes it's the case that when you fix one bug, other bugs that were sort of masked by that bug are revealed to you. So you have to, go through and squish those bugs too. So regression testing is basically insurance that you're not reintroducing old bugs. Because one of the ways in which fixing a bug can reintroduce a bug, or it can introduce a bug, is not create a new bug, but reintroduce an old bug. So sometimes when we fix bugs, we don't fix them well. It's possible to fix a bug without understanding the bug, right? This is what's referred to as the kludge. That's programmer lingo. Kludge. So this is one of my favorite Wikipedia. Thank you. This is one of my favorite pictures of all time. This is a kludge. this is sometimes what your software looks like. You can't address the underlying problem, which is, in this case, the fact that the bridge has snapped in half. So rather, what you do is you just build a, sort of a temporary fix over top of it. The temporary fix, unfortunately, as is the case often with government projects, the temporary fix often becomes the permanent fix. But you can imagine how, when you're fixing bugs, sometimes the fact that there's a bigger bug that remained sort of unfixed but was gotten around, that can be reintroduced. So what you do with regression testing is you set up a few test cases that will show known bugs that have been fixed. Because there is a difference between fixing a bug and fixing a bug in software. So in regression testing, you want two test cases. You want one that fails if the bug is present, and you want one that passes if the bug is fixed. You keep both of these test cases around, and that way, if your development of your software reintroduces an old bug, you will be able to catch it before it's shipped out to your customers. It is also possible to have continuous integration testing. So the degree to which testing occurs, testing can be performed in a sort of semi-automated or even a completely automated manner. One way of doing this is that you can build things into repositories. So this is kind of tricky because I don't think we've talked about code repositories yet. But essentially what a code repository is it's a way of managing a software project. When you've made a certain amount of progress on a software project, you upload your progress to a repository. One of the most common and one of the most commonly used ones is called GitHub. The mascot is an octopus/cat. They were bought out by Microsoft a couple of years ago. So when you can configure GitHub in such a manner that you can supply it with some test cases, and whenever you make an upload to GitHub, it will automatically check to make sure that your code is still passing some particular test cases that you've said, I want to test this on a continuous basis. I want to make sure this is never false. So there you go. So how does one go about... before we get into the slide, let me see if we have any comments. Yes. Okay, cool. So how does one go about developing these test cases? Well, there's an art to it. Writing test cases for software is it can be as involved as writing the software itself. You may notice this because every once in a while, hopefully not too often, when we have written a bunch of new test cases for a test in the we make you write a test sense, sometimes there'll be a problem in one of our test cases, and that test case sort of, has some sort of a bug in it. Normally, the student populace of like the you kind and friendly folk who take this course, normally you guys are very good about telling us when the test cases are bad, or when you think they're bad. So, test cases themselves can have problems in them. So, generally speaking, we try to follow, with the test cases that we use to grade your assignments, the same sort of general good design philosophy that we're illustrating here in this slide. So, if you're testing, let's say you had a function that, Well, let's use the old factorial function as an example. Certainly, you want to test it for what I usually call nominal test cases. That is, this is generally what it's supposed to do. Can you calculate the factorial of 5 correctly? Can you calculate the factorial of 10 correctly? Nominal test cases. You also want to test what are called edge cases. So edge cases are, generally speaking, basically what edge case testing is you want to test to make sure that the conditions in your code are hitting the correct mark. So if you imagine, the classical example of this is when you're running through a list, right? So you want to make sure, let's say you're calculating the maximum element in a list, right? You want to make sure that every single element of the list is tested, right? Which means if you're using a while loop to loop over each index value inside of that list, you want to make sure that I actually travels from 0 to the maximum index in that list, which is the length of the list minus 1. If by some perversion of justice, shall we say, you're going from 1 to the correct value rather than from 0 to the correct value, your test doesn't include the 0th element, right? The first element of the list, if it is the maximum, will not be detected as the maximum, and that can be a problem. So, generally speaking, we test edge cases. We test to see, if the maximum element is the first element, do you pick it up? If the maximum element is the last element, do you pick it up? If the maximum element is somewhere in the middle, do you pick it up? What does your program do if the list is empty? That's one that we use quite frequently. So, because hypothetically, another thing that you should have a good idea about is the behavior of your program when the inputs aren't exactly valid, right? So, if you're taking the maximum of a list that contains no elements, what is the maximum of nothing? The answer is, well, we can do it a couple of ways. We can bake in the assumption that the list has at least one element in it. Plus, we can do something like return false, well, although we'll see how that's not the best way of handling it. Or we can introduce an exception, which we'll get to in a bit. We can introduce an exception that tells the computer, basically, hey, I received invalid inputs on this function. What do you want me to do? So, yeah. Let's see if there are any questions. OBS needs bug-fixing test cases to prevent this. Yes, I agree. Sometimes... Oh, my goodness. Has it happened again? Jesus Christ. That is a funny one, though. If any of you are screen capping these, that's a good one. Yeah, and the mic's gone, too. It can be a little bit... Sometimes... Yeah. Sometimes what goes on with these particular things is... the way that these peripheral devices work, essentially, is that they are considered a common resource which is shared by the entire operating system, right? So I have a suspicion that what's going on here is some update routine or something is happening within the context of the operating system, which sort of touches and performs some kind of reconfiguration on these guys, and that resets them to like where they're located. It probably, like, to me, I don't think it's OBS. I think it's my operating system, but you know, it's equally annoying whether it's one or the other. But like one thing that's kind of interesting is I've got a color slider, right? So like you can modify the camera configuration in OBS, right? Hue. Like I can pull this guy, and it used to work a lot more pronounced on my old webcam, but like I can change the color configuration of the picture, right? And in so doing, these settings are actually globally applied to all video feeds that come out of my computer. Like, for example, when I log into Teams after this to do the office hours, this color scheme will be maintained. And I think it's because this is modifying values in the operating system and not modifying values inside of OBS. So, oh, there we go. Turn off white balancing and I could get lots of colors. But yeah, so bugs. So that's class. If you guys have any questions that are sort of related, pertaining to the lecture rather than pertaining to stuff that you would ask in office hours, then please feel free to do so at this point in time. And otherwise, I'm going to log off, get myself a drink, and hopefully not spill it on myself. And we can have our office hours, which I imagine will be quite a lot of people there, considering there was a test that was returned this week. Generally, that's the case. Yes, yeah, my office hours are presently. Again, it'll be, I don't know. I'm normally a couple of minutes late, but, you know. Yep, there is a pink filter. I modified the hue value. I can put it back. Last time it was, last semester I was doing funny stuff like being orange for Halloween. I don't know, this camera doesn't seem to have the same range as the other one. Like, if I do my regular webcam, which is built into the laptop, it's got a lot larger color range. Or maybe it doesn't. That's weird. Huh. Well, whatever. Don't want the government looking at me as I'm doing nothing particular that I wouldn't want the government to look at. Nothing to hide here. I actually do have nothing to hide. I live a very boring life. I once heard an analogy that being the NSA must be like it must be like playing Dwarf Fortress, watching all of your dwarves play Dwarf Fortress. Green for St. Patrick's Day. Oh yeah! Yeah. Yup. Green for St. Patty's Day. Perhaps next week we'll have St. Patty's Day green. That's a terrible... I could do a better Irish accent than that. Jeez. Alright. Well, that seems to be it, so I'll log off here. Thank you, everybody, for listening to this old fuddy-duddy talking about computers and junk. See you in office hours if you're coming.